During spring semester 2017, a group of 8 undergraduate students and 2 faculty members from the Environmental Science and Technology Department at the University of Maryland visited Biosphere 2 as part of a travel study course. One of the goals of the course was for the students to set up 3 replicate algal turf scrubbers, also known as ATS, to remove nutrients from the water in the marsh biome tank. This video, which was produced by one of the participating students, Elizabeth O'Keefe, illustrates from start to finish the process of setting up the ATS. Most of the students in the class were in the Ecological Technology Design major at University of Maryland, which focuses on ecological engineering applications such as the Algal Turf Scrubber, constructed wetlands, and stormwater management systems. The process of setting up the ATS in Biosphere 2 is a great example of the hands-on design experience which characterizes this academic major. The first step was to move the ATS into Biosphere 2 and position them on tables so they would receive maximum sunlight. The main driving force for nutrient removal by the ATS is photosynthesis of algae on screens, so the exposure to sunlight was central to the project's objective. Next, the overall strategy for plumbing the ATS was presented to the students. The challenge was to splice into the existing water circulation system in the marsh biome in order to bring water to the ATS and then to return the water back to the marsh biome tank after it had passed over the algal turf. The students were asked to design the plumbing system as an exercise, and then their individual plans were discussed by the group. Dr. May settled on a final plumbing design, and the appropriate component parts were purchased from a local supply store. Students were divided into groups to work on separate sections for the construction of the plumbing network. They were given training on plumbing techniques, tool use, and safety, and then the work began. The design work of the project was supervised by Dr. Peter May from the University of Maryland and the environmental consulting firm Biohabitats in Baltimore, Maryland. Dr. May has a great deal of experience in building and operating ATS, and he kept the students focused since only a short amount of time was available for this project. The ATS is an ecologically engineered technology used to remove nutrients from a water body. This also produces biomass, which in turn can be used for several other purposes. This technology was developed as a lower-cost, more environmentally compatible alternative to conventional technologies for water quality management. The algal community provides water treatment by uptake in photosynthesis of nutrient pollutants such as nitrogen and phosphorus. Water is pumped from a water body onto the raceway, and algae remove the nutrient pollutants through biological uptake during their growth as the water flows down the raceway. The nutrients that have been removed from the water are stored in the biomass of the algae growing on the screen. The algae are harvested approximately once per week, thus removing the nutrients from the water in their biomass. Attachment cells of the algae remain on the screens after harvest, and the turf community quickly grows back from these cells between harvests. Because of the fast growth rate of algae on the ATS, this technology can remove nutrients at a high rate. Harvesting is important since this action rejuvenates the algal community and leads to high growth rates. The 3 ATS shown in this video were originally used in a research project at the University of Maryland. Each of the ATS units is 1 meter long by 1 meter wide, making a surface area of 1 square meter, and they each weigh 41 kilograms. They are constructed of fiberglass and include a tipping dump bucket at the top of the unit where the water is input into the system. The dump bucket is an important part of the ATS system because it generates turbulence that stimulates algal growth as the water passes over the turf. The ATS are small-scale experimental units that will be used to measure the rate of nutrient removal in units of milligrams of nitrogen and phosphorus removed per square meter of algal turf area per day. This information can be used to design an ATS system for long-term water quality management in the marsh biome. The plan is to operate the ATS for 6 months with measurements of algal productivity and nutrient removal rates. Algae from the marsh biome tank colonized the screens soon after the water flow had started, and harvest began within a month after the system was constructed. The data will be published, and the information will be used by the University of Arizona staff to assess the viability of the ATS for water quality management in Biosphere 2.